Awesome. Thanks, Tim. And thanks everyone for showing up. I realize it's quite late in the day if you're on the east coast of the US, and the last session of the day is always the most fun. A bit about me. I'm a technical account manager working with Amazee.io, based out of Wellington, New Zealand, and I do kind of work with some of our largest customers with the most curly problems, both in region and globally. And you'll find me on Drupal.org and Twitter under @witham, and you can send me an email there as well. And for those who don't know where Wellington, New Zealand is, I drew a handy dandy little Google Maps diagram for you. Not that you can actually fly here at the moment due to COVID, but if you could, it'd take you over a day and a lot of money. Probably a lot of layovers as well. It wouldn't be very fun. But yeah, we're basically the other side of the world. We're UTC +12 at the moment, about to go into +13. So it's Friday for me at the moment. And yeah, I'm in the future. It's all good. And yeah, just a quick shout out to the organizers and the sponsors and everyone here. Just thanks for letting me present, and really appreciate it. This is not normally something I would be able to do. Traveling to the East Coast of the US is a Herculean effort for me. So having it virtual is pretty cool. So a quick agenda so that you roughly know what you're in for. I'm going to try to split through overviews in 1 minute, so we're not holding everybody up. I'm going to talk about COVID-19 and what this meant for one of our key customers. I'm going to talk about some scary numbers that we ended up dealing with. And then probably more what you're here for is how. So the horizontal scaling, the database scaling, in-memory caching, and minimizing origin hits, and optimizing the CDN. And ultimately, why should you care about this stuff? So here's a Amazee.io in 1 minute slide. For those who are not familiar with Amazee.io, we're a fully remote team, and we're open source at the heart. We're all over the world, and we work with our customers 24/7. And it's our mission in life to kind of keep things running as smoothly as possible at all times. And I guess some of the unique parts of us is that you can host in any cloud provider of your choosing in any region that they support. And everything, including our hosting, is open source. So we have a product called Lagoon that is what we use to actually deploy your site. And we're committed to transparency, and I think the open source nature of that actually really helps to keep that. And we do a lot of work with government, financial and education, but what I'll be talking you through today will be largely government related. And the customer I'll be having a talk about is called GovCMS. And for those who have not heard of GovCMS, which is probably likely if you're in the US, it's actually based in Australia. It's run by the Department of Finance. It's a Drupal hosting platform for federal, state, and local government in Australia. And we partner with Salsa Digital to help deliver the solution. And it's been running in production for close to 5.5 years. And as of today, there's something like 329 sites live, and they're all different shapes and sizes. Like, got some really tiny ones, some really big ones, and everything in between. It comes in 2 flavors: software as a service, or SaaS, which is for the agencies with very little developers on staff, or maybe they're after something a bit simpler, and they just can bring their own theme, which is often all they need. And GovCMS is also in a PaaS, or a platform as a service model, where you can actually bring your own Drupal code base. So obviously that second option requires a development team, either in-house or out-house. but usually a lot more money because of that. And GovCMS also takes care of the security accreditation at the platform level. And if you use SaaS, it actually is for the application level as well. So it basically cuts through all of the, the assessments, and they're called IRAP down here. It's kind of similar to FedRAMP, I guess, in the US. And just a shout out to John and Adam earlier today. If you haven't already seen it, I would probably recommend seeing it. I'm going to catch up on it because it happened at silly o'clock in the morning for me. But platforms, multi-sites and platforms, it sounds really interesting. But GovCMS in this instance would be a platform. It used to be run as a multi-site and now it's not, but it's still got a lot of sites on it. Quick disclaimer, I'm going to try not to use jargon. So I'll try to spell out every single acronym and I'll try to explain it where possible. I will mention things like Kubernetes and containers. No existing knowledge is required. And I'll try to explain some of the concepts using extremely weird metaphors. So hopefully that makes things a bit simpler. Cool. So COVID-19 and what this meant. So GovCMS hosts several sites that were impacted by COVID-19. So we've got health-related sites. So this is health.gov.au. This is the authoritative source of all COVID-19 information in Australia. So everyone links to this site, and it got busy real quick. We also look after a site called Smart Traveller with one T, which is bizarre, and Smart Traveller is like for people that were considering travel overseas or that were already overseas and were looking to get back, and just what the government's sort of stance on certain countries were, whether they were okay or whether they're not okay. That was quite busy towards like February, March, and sort of has teetered away since. And government payment related sites. So for anyone that lost their job due to COVID, the government in Australia announced something called a job seeker payment. And as you can imagine, that got quite the influx of people looking at it to work out what they could get, what they're eligible for, etc. So some of the numbers that we actually got, and these numbers I'm about to show you were largely captured in late March. We're talking like March 26, around that date. That's about the date that things got really crazy. So on the SaaS platform, so these are just the sites that on like probably like half of GovCMS. There was 187,000 concurrents in Google Analytics, and a concurrent user in GA is someone who has done an action in the last 5 minutes. So these people are basically on all your sites, clicking around like mad, searching, sorting, downloading, doing all sorts of stuff. And if you've ever seen GA go to this number, it's really scary. So yeah, it was certainly something to behold. The health site actually has a mobile app, a native app on Android and iOS, and they were doing push notifications. And in the early days, they didn't stagger them. They just pushed them to absolutely everybody at the same time. And there's about 24 million people in Australia. So yeah, in the peak minute after one such push notification, there was 100,000 page views in the peak minute. So that's off the charts. In the peak day, we saw around about 8.4 terabytes of bandwidth at the CDN. And at this kind of scale, when you have a PDF on the health site, it actually matters if you optimize it or not. So if it's a 5 meg PDF or a 200 kilobyte PDF, that could actually result in a bill reduction if you actually just go to a little bit more effort to optimize it. So a lot of the problems you don't have with small sites become problems when you have this kind of traffic. And the health site itself actually had an 80x traffic increase if you take month on month from February to March. So on top of the platform just generally going up by a few factors. One site actually went up by a lot. And this is probably the best representation of COVID and GovCMS and the impact it had. So you can see back here in, what are we, July 2015. This is when GovCMS started, and I still remember when GovCMS had 1 million page views a month. Now it's a pretty big deal. And as more sites sort of came along, each color sort of represents a site, so you can kind of get a gauge on what's actually on the platform. And obviously the bigger the bar, the more page views they have. And this kind of gold color, I'm not too sure what color that is, but that's the health site. So you can actually see from February to March here, it actually just, kind of went through the roof. So that's, yeah. And that's largely just at the end of March too, not so much the beginning of March. And yeah, you can see COVID, even though it's still with us, it's like the traffic to the site is still not back to, quote unquote, BAU levels. So how do we end up dealing with this traffic? The first thing I'll talk about is horizontal scaling. And I define this as just being able to increase your application resources in response to traffic. And ideally, this happens in an automated fashion, because if you need to call somebody up, raise a ticket to say your site's down, well, it's kind of a problem, especially if you're servicing the health related information for the entire country. So yeah, being able to respond to traffic and do that in a fashion that just kind of works itself out is absolutely ideal. And Amazee.io's Lagoon is actually running a technology called Kubernetes. And inside Kubernetes is something called a horizontal pod autoscaler, or HPA, and a cluster autoscaler, or a CA. Now you're saying, Sean, what the heck is a HPA and a CA? Like, I don't understand your silly words. So I decided to come up with what I think is the closest approximation to you do this in actually real life, is say you go to a supermarket and there's 2 checkouts open. This is what you'd probably call the minimum number of checkouts, right? And people line up to get their shopping scanned and make payments, etc. And maybe there's a bit of a backlog of people waiting to get their stuff scanned. So at that point, a checkout supervisor might go, hang on, this isn't optimal. We can actually reallocate some resources to actually open up additional checkouts so that we can service more people at the same time. And then if we just take this one step further, the checkout supervisor is actually the horizontal pod autoscaler. The checkouts are pods, and the people are actually HTTP requests. And now you know Kubernetes. Well, not really, but you get the idea. If we take it sort of metaphor slightly further, which I don't know if it works anymore, it might completely break it, but if you were to expand the supermarket, add more room so that you can fit more checkouts, well, that would be the cluster autoscaler, so that you'd actually have space for additional pods in this case, so that if you needed to, you could run more checkouts. So during this HPA kind of scaling for GovCMS, we actually developed this new concept called a COVID HPA, which is if you're a COVID related site, then you're going to get something a little bit different from a regular site, quote unquote. And we're going to set your minimums to 4 pods, your max to 12. So this is quite a lot. And we're going to actually drop the level to which you scale, so you scale much, much quicker. So the horizontal pod autoscaler will actually do a check every 30 seconds to see if it needs to scale. So what we did was just basically say, well, when that check runs, just be super aggressive, err on the side of adding pods. And we actually did daily reviews. This is March, April, of every single COVID impacted site, just to make sure the HPA was just as close to optimal as to what it should be. Because ideally we want to reduce something called pod flapping. And if we take this back to the supermarket analogy, you don't really want to open a checkout, service one person, then close the checkout, and then next minute open the checkout, service one person, and then close the checkout. That's not super efficient, and you just have people running around all day doing busy work, not actually doing any actual work. So yeah, we call this pod flapping, because pods come in and come out, and we don't really want that to happen super frequently. And to kind of put this into graphical form, this is actually one of the sites running on GovCMS. Each color represents a pod, and the y-axis is number of requests, and it's split by minute. And this is roughly for a 7-hour period. And if I get zoom out of the way, you can see in the left here, we start the day with 4 pods, and we've got roughly 500 requests per minute. This is to origin. And you can see this is the first instance where an additional pod comes in and then kind of goes away. Pod comes in, kind of goes away. And then this orange pod actually stays with the cluster for the remainder of the day. And then we see another pod come on top. So this place we're actually up to 6 pods serving traffic. And where it gets kind of really funky is about this point here, where we see a spike that takes us from roughly 1,200 requests per minute to 3,100. And yeah, we can see during this point, we actually have 8 pods running. And if I was to tune this HPA for this site, I probably would say that 4 is not enough in general for this site right now. And 8 is probably good for the spikes, but during kind of business as usual, quote unquote, I think maybe 6 pods would be kind of good. So what I would do to this site, I'd raise the minimum to 6, just to avoid this kind of pod flapping around here. And let it scale naturally for these 2 events during the day. Yeah, and probably the final thoughts on the HPA is like, there's no right and wrong answers. You just try, you measure, and then you see if that's improved the situation, and then you just give it another go tomorrow or the next hour, or and just constantly refine and keep going. And like with COVID, we had no idea what was going to happen the next day. We didn't know if the Prime Minister was going to get up and say something, whether there'd be a push notification, whether there would be a mass, messaging to people. It was very much just ride the wave and do your best. Now onto database sizing, scaling, and tuning. So as some of you may know, Drupal loves to send database queries. And if you scale your application layer, that's cool. But, if you've got only a database which is, like a fixed size, then that's quickly going to become your bottleneck. You can run a database in a pod, but I'd say this is a poor life choice, because one pod is not highly available. And there was another session today that Sunil did called Drupal hosted on Kubernetes. So if this is triggering something for you guys to maybe want to learn a bit more, I'd probably check that session out. It goes into probably a lot more detail than I will here. So what we end up using a lot with Lagoon on AWS is AWS's Relational Database Service, or RDS. And specifically a flavor they call Aurora, which is a fork of MySQL, which is got some goodies in it, let's just say. One of the goodies is faster failover with no data loss. And no data loss is pretty cool when you want to failover. And this is roughly what an RDS cluster looks like at its simplest form. We have a writer instance, and we have a read replica, which receives any changes in the writer and get replicated to the reader. Your application, your Drupal application, will typically just point at the writer, and it never needs to know like this kind of level of detail. But say the size of the cluster instances are currently large and large. I didn't use any AWS terminology here, just used like large. But say you want to make them bigger. because say you're under a lot of stress and on the database layer. So what you do in Aurora RDS is you can actually upsize the reader first. So you can actually go to this guy here who's not actually receiving the queries from Drupal, and you can upsize him first. This process takes you know, a few minutes. And then once it's been done, the replication will kick in and it'll catch up. And yeah, now you've got a size X large, say. And then what you can actually do in RDS is actually, it's called failover. So you fail the writer over to the newly upsized instance. And then what this will do is flip the replication backwards. So it's going back to the new reader. So this process is DNS based, and it typically takes like up to 10 minutes for all the queries to kind of migrate their way over. And then once you've got all the queries going to the new writer, you can actually upsize the new reader. And so now you've actually upsized the entire cluster. And you can do all of this whilst the application is running. So yeah, yeah. No one ever upsizes their database when it's running with lots of headroom, right? So this process always happens under peak load. So you better be good at it. And yeah, God bless RDS Aurora, just makes it a lot easier. So end to end, I think it's around about 15 minutes to upgrade an RDS cluster size. And this is from actual testing, but we saw roughly 50 HTTP responses result in 502s in a 30-second period during one of the peak events on one of the sites. So it's not entirely seamless to the end user, but when you're getting like 3,000 requests per minute, like 50 is, you know, probably not the end of the world. And we ended up upsizing Services Australia twice in a period of, I think, 2 days. So it's actually 4 times larger than when they originally started. And you might ask, well, how do you know when is it time to upgrade the size of RDS? Well, that's a great question. Amazon provides this tool called Performance Insights, and I really like this tool. It's really useful. It's kind of like it shows the load on your database by either by query or by user. And this little dotted line here, show max vCPU. We're looking at a R5X large, I think, cluster here. We've got 4 virtual CPUs. So ideally, you don't want to have the queries that it's currently executing exceed the CPU limit. It's, yeah, the queries will run slower and they'll start to pile up and things will get a lot worse before they get better. So in this case, you can see that the database was fine here, and then at this connect towards this end of this period here, we start to see them exceed this limit here. So if this was going to be a sustained occurrence, then I would be considering doubling the size of this cluster. This is an example of a much happier RDS cluster. Here you can see it's a much larger cluster. It's got 16 vCPU. But you can also see that the max concurrent threads running is roughly 7 during this 5-minute period. But generally it runs under, say, 3 or 4. So this is a much happier and healthier RDS cluster. My other pro tip in Performance Insights would be to avoid the 1-hour time frame. Instead, use the 5-minute time frame. And the reason being is this is a 1-hour time frame. Everything looks rosy when you look at this. Everything looks like it's under like 1 or 2 concurrent requests. But if you look at the 5-minute, this is the exact same cluster. If you look at the 5-minute version, you can actually see these spikes that actually occur, which you don't get the kind of visibility of. So I would encourage just everyone to just use the smaller granularity and just actually see what the end spikes are getting up to. In-memory caching, so super related to database scaling and performance is in-memory caching, because if you're using the database as your cache system, then you're going to find a lot of problems with that. It's going to send a lot of cache queries to the database. Your database is going to quickly get overloaded, and to be quite honest, it's just not the fastest way of doing things. You want a pure in-memory caching system is going to be a lot faster. So at UPSIZE, we love Redis. It is a key value store, and it's all held in RAM, so it is super quick. And we have two options for Redis. You can rock out a Redis pod, which is not highly available and can be considered a single point of failure. Or you can use Elasticache, which is an Amazon service, which is highly available and replicated across many availability zones. So yeah, when is it time to not use a pod? Well, if you require high availability, I definitely would not use a pod. And we also saw one of the sites was sending 60 megabytes a second to its single Redis pod, and Redis was not having a happy time. So yeah, Elasticache is definitely a much better option for anything that requires those higher performance figures. And probably the last thing is just ensure that you've actually configured a Redis timeout. So yeah, we don't want to, if Redis ever goes down, you don't want your Drupal app to go and sit there and wait for it for 30 seconds, because then all your page view, essentially your site will just die slowly and terribly. Minimizing origin hits. So even better when it comes to scaling is to never have to generate the page view on origin and rely purely on the CDN instead. So we do a lot of work with Elasticsearch and Kibana, and I'll show you actually one of our dashboards that we've set up. And I realize you won't be able to read it, but I'll walk you through the dashboard. So this is Kibana. We can see it's showing, this particular case, HTTP status codes broken down by minute for a particular site. Green is all 200s. There's some 304s and 403s and stuff like that as well. So this is generally quite happy. We see top 404s by path, and we see the lovely Apple Touch icon. Always seems to lead the pack there. You've already seen a form of this graph already. This is, we call it project scaling graph, but it's a measure on how many pods are currently running, and are they adding new ones in, etc. At the top, requests by path and method. So just generally what requests are going to origin. So if you were to fix up one thing on the site, favicon.ico, like at the moment, it's having a lot of requests being sent to origin when potentially that could be cached at the CDN. There's another related graph, which is actually sorted by PHP time aggregate. So the favicon ICO is probably going to be really quick to serve because of fast 404 if you don't have the file in your doc root. So another graph here is actually, if you were to optimize any actual path because it just takes so long to generate, then you can look at these ones. So this is actually the COVID-19 kind of news article main landing page here. So if they were to optimize anything, changing the cache lifetime of this might be the easiest way to improve performance. And lastly, user agents over time. So if you're getting hit by a bot, then this is going to highlight that pretty quickly. And the red color you see here is actually funnelback, which is a crawler crawling their site. So it sticks out like a sore thumb. And yeah, it's just kind of highlights that. So yeah, this is the dashboard that we created. You can substitute any site as a filter, and if someone goes, hey, is this site okay? Which kind of happens all the time during COVID. Then you just bring up the dashboard, plug in the URL, and then you're away laughing. And then you can have, at a very quick glance, sort of say how healthy the site is, or whether you need to make any adjustments, whether there's anything the application teams can do. or the CDN teams can do. So now that you're armed with that information, well, how can we make the CDN a bit better? So the main thing I'd say here is, choose a CDN provider that's a major player, because life's too short for having outages at the CDN layer. So, GovCMS uses Akamai, but there's several others that would be that would fit into that kind of category. Having DDoS protection, a WAF, and some way to manage bots, I think is a really great idea. Serve while stale, I could probably talk about that for an entire presentation, but for now, just know that it exists. And if your origin generates a 500, that doesn't mean you need to serve a 500 to the end user. You can actually serve the last known good response, even if that response is no longer valid. Negative caching. So if you have a 404, like, what's the point in asking Drupal like 50 times a second for the favicon ICO? Surely if it's a 404, it's going to be a 404 for the next, like, say 10 minutes. So negative caching allows you to do that. Background refresh. So rather than have users experience the Drupal page load time, which can be like 200 milliseconds to a second, why not get the CDN to do it for you? And that way the users experience very snappy page loads 100% of the time. And if you're not using Drupal 8 or 9 cache tag and validation, then, get onto it. Like, it's honestly the main thing that's going to improve your cache hit rate. And I think this is often worth thinking about, especially during COVID, but what if you have a catastrophic cluster failure on the back end? What is the next best alternative you can serve to the end user? So having a static fallback or some way to serve something which is better than an error page is often going to be something smart. And to that point, this is kind of like, I've touched on this a lot during my presentation, but you want to build this kind of culture of making continual small improvements to an overall platform and each site, and kind of get into that mindset that you need to keep doing this. So this process is called Kaizen. It's a Japanese word that was, of course it's Japanese, invented to, I think that it was used at Toyota on their production lines, just if they could optimize anything, then even a small process, then it would overall add up to a lot. So it's this build, measure, learn cycle. So you do something a bit different, you measure its impact, and then you learn a lesson from that, and then you take that into the next time you'd make a change. So some questions you can ask yourself here is, how high can you get the cache hit rate? I've been on the site before where we've had 99.975. And when your cache hit rate is that high, it doesn't matter what your origin's really doing because the CDN is doing all the work for you. What requests are using your backend resources that you can avoid? When was the last time you actually looked at the slow query log in the database? What are the top 404s in the site? Can you avoid them? Can you put a file? Can you create a favicon.ico and stick in the doc root? What version of PHP are you running? Is it 7.4 or was it something slower? Are you using cache tag purging? If not, why? And when was the last time you actually reviewed what cache tags you're trying to purge? Maybe you shouldn't be purging some. And just in general, like, encourage your team to find ways to improve the platform. And you're never done. You're just on the journey. And I found this on, I think, LinkedIn, but it's called the 1% principle. But if you make something 1% better every day of the year, then you actually add up to a heck of a lot. And, I realize that adding, 1% of performance to a site every day is going to be quite a struggle, but maybe you could add 1% to each site on the platform every day. And then over time, this will add up to a lot. So I just think, yeah, this is quite powerful, and I've certainly seen this in reality with GovCMS, because ultimately this is how we ended up surviving COVID, was by having these processes in place, you know, this culture of always improving the platform in place prior to COVID actually coming on. And you know, when it did come on, we'd actually, you know, there wasn't too much of a, like, you know, there was no serious concerns there. And why should you care? So kind of like a final slide here is, this is a quote from Services Australia, which, you know, this is Susie Smith, one of the GMs of comms. And I thought this really kind of highlighted the work that we were doing, and yeah, made all the work that we're kind of doing behind the scenes worthwhile. So it meant that we're able to supply information to the public during a pandemic with no outages. This supported real people and their ability to care for themselves and their families. So it's actually kind of heartwarming, that. So, and Services Australia were the site that went through the double database upsize, the, you know, I don't know how many times they tuned their HPA, but yeah, they're now in a much happier place with their stack and their tuning. So if we get a new spike in cases or anything like that, I'd have no qualms in looking after that. And that's the end of the structured content. Hopefully I haven't gone too far over there, Tim. Happy to take questions and answer anyone's burning topics.
Sean, you didn't go over it. It was great. Great
Perfect.
Presentation. Thank you so much. Still got a couple minutes here for the questions. So
got one for you, Sean.
Yeah, go ahead.
Yeah. So what was like the ratio of authenticated to anonymous traffic that you had to deal with? Because it seemed like a lot of traffic was bypassing your CDN, and you had to do some clever stuff on the database.
So a lot of the traffic that was passing the CDN was post requests, so people filling in forms, people searching. It's tricky to cache that at the CDN. To answer your original question, most sites on GovCMS are unauthenticated. They're pure anonymous users. But a lot of sites on GovCMS aren't using cache tag purging either. So just by virtue of just having a fixed cache expiry, there's a lot more traffic on Origin generally for some sites. So yeah, but if they were authenticated, what I just described wouldn't change. So you just probably have a lot more aggressive HPAs, and you'd have a lot more resources in your database layer and Redis layer to deal with that.
Hey, so we had one question in the chat early on that Elijah asked, is GovCMS based on Lagoon?
So Lagoon is the hosting kind of platform that Amaze.io helps to support and manage. And GovCMS is the kind of like distribution platform. I don't know what you want to call it exactly, but it runs on top of Lagoon. So the sites that are being deployed, Lagoon deploys them. And yeah.
Great. And then there was a question that I think you answered. Was the scaling just for the PHP, and was there DB scaling, which you touched on?
Oh yeah, there definitely was DB scaling. Don't worry about that. Yeah. So for those that care, we typically run quite large database clusters. We typically have, we had to shard them because we've got so many sites. So we've got, I think, running 5 RDS clusters now for GovCMS. And they're all behemoths. So yeah, they're scary large now, which is, it's kind of fun. But yeah, performance insights, ++, really love it.
Tim Cosgrove had one earlier. Was sort of what Adam asked. What percentage of the traffic was authenticated, and/or dynamic. It seems like potentially the job seeker assistance site would be very individual focused, whereas travel advisory would be static content. And
yeah. So
yeah, he pretty much answered that with Adam's
good,
question.
okay.
Yeah.
It's largely static. So for the job seeker payment, the Services Australia site is informational and it links off to a portal, quote unquote, that users can actually log in using their government ID and actually complete the process. So the Services Australia site is more about providing the information about the job seeker's payment, who can apply, what the requirements are. That type of thing, rather than the transactional side of like, where's my payment, stuff like that. So yeah, I mean, that would be a lot more scarier, because I mean, that actually had they had a lot of people hitting it, as you can imagine, during the early days of actually signing up and applying, and they were hosted on some proprietary platform, the actual back end of it, and they were actually struggled to scale because of license fees. So if anything, familiar. I think, it's probably not talking to anything new here, but I think that's one of the cool benefits of open source, is that to scale Drupal, you don't need to pay a Drupal license fee. Like, how amazing is that? I don't think we talk enough about how cool that is. And just if you want to run more pods, you don't need to go pay someone. Like, can I please run more Drupal? That's pretty neat.
Hey, Sean, did anyone ever, as part of this, consider like breaking off the gets and the posts to like separate infrastructure? Because I know that's like one bag or one thing in the bag of tricks for stuff like this too.
So yeah, the post requests we weren't too concerned about because of the bot management layer inside Akamai. So the posts we were getting were legitimate. So people actually filling in the search form and stuff like that. So there's some tricks you can do, like in Drupal, like if you want to avoid a post request for some form. So the search form is a great example of when you type, search for like job seeker payment, enter. That will normally do a post request to Drupal. Drupal sends a 302 response to a search $keys equals job seeker payment. It turns out you can just do that with JavaScript. So that's probably my first pro tip there, is don't send a post request if you don't need to. And I didn't really touch on it, but if you use views, just turn off the Ajax tick box. Like, it looks cool, don't tick it. Just use a pager, because a pager is a GET request and is bookmarkable and all the other cool things that it should be. But in terms of splitting the clusters, like, we are able to split the clusters if we wanted to, and we are actually starting the process of doing this with GovCMS already, just splitting off some workloads into dedicated Elastic Kubernetes service inside of Amazon. And the idea being that if you want more hardware isolation from other applications running, and your own scaling profile, then we can deliver that. For now, like, GovCMS runs in a supercluster, so to speak, with a lot of pods and a lot of fun.
There's another question there, if you don't mind reading it, from Tim Cosgrove in the Zoom chat.
I can read it. Oh yeah, sorry. Sure. No, I was just going to ask if you're the WAF rules that you were using, did you have to tune those or contribute to them yourselves, or did Akamai just sort of provide those as part of the service? And also, I was wondering if you had to go through a report only phase where you were ensuring that they were excluding legitimate traffic, or did you just block stuff from the get-go?
Great question. So Akamai the short answer is yes, we had to help tune it. So by having that visibility into Kibana and Elasticsearch, we're able to find what's actually hitting the back end that potentially shouldn't be. A great example is that we didn't know ahead of time was that if you have, say you send someone an email with a Word attachment or a link to a Word document that's actually hosted in Drupal's public files, Word will send an options request to the folder that that file sits in. And that sounds cool, but then you end up with all these options requests, just like what is an options request doing hitting your backend? And turns out it's just like Excel and Word. And so, yeah, that's never going to trigger a WAF rule by default. So what we ended up doing was creating a WAF rule to say like, hey, when the user agent matches Microsoft Office, star, and method is options, then Akamai's got this cool feature called tarpit, which I really, really love, which is not block. It's just don't answer them. Let's leave them hanging.
It's like shadow banning almost, kind of.
Shadow ban, yeah. So all these, especially good for like bots and stuff, because it actually ties up their resources, because it's waiting for a response, and typically they're running at a concurrency of like 10 or 100 or something. And so if they only got 100 threads and they don't return, then they don't send anymore. But yeah, we're constantly refining those rules. There's a lot of bots out there that are just absolutely silly, and some of them will just be crawling the entire site. Sometimes it's just people running like dirbuster and gobuster when they want to just find out what paths and directories are running on the site, which is just super frustrating. But yeah, there's a lot of features in Akamai I could talk about here, like client IP reputation, really, really cool. That runs across the entire Akamai network. And if you want to be a bit more aggressive on the filtering of people, let's start with client IP rep, because yeah, that's super handy. And the other one is bot manager. So bot manager works out roughly if you're a bot or not based on sort of patterns and heuristics of the request. So it knows if the request originates from, say, DigitalOcean, that's going to be a contributor to working out if you're a bot or not. And yeah, maybe that combined with the fact you don't have a user agent header, we can put 2 and 2 together and put you on the target.
All right. Anyone else have any questions that weren't answered? It looks like Salim maybe is happy with the question Tim asked. They're related or the same.
And yeah, we did go through a monitor phase for Akamai. Yeah, like whenever you change a bot manager rule, for instance, you don't want to just turn that on. Yeah, you want to make sure you understand what you're about to block and then pull the trigger.
All right, well, thank you so much for your presentation, Sean, and participating here, and everyone for listening in and joining. We'll end it there.
Appreciate it. Yeah, thank you all for having me. And I'll put the slides up on the website. Yep.
Session page. Thank you so much. All right, take care, everyone. See you tomorrow.
Thank you.
Bye.